Hi, in this lesson I want us to finish off the work we've been doing on folds. We've seen that folds can occur on all sorts of different scales, even with this satellite image of part of northwestern Australia. This is the same type of area uh, you've been watching in the video uh, on Kimbolton. We need to explore just a little bit more about these really important geological features that, uh, in this case, can even be seen from a satellite. Before that, though, this would be a good moment to revisit what's in a word. You have a whole series of terms here, all of which apply to folds and faults. What I'd like you to do is go back to what's in a word and can we come up with definitions for these? What do you think now? What are the meanings of these terms? All of which we've now seen and been introduced to. Have a go at that now. Okay, let's have a little look at this area of Kimbolton. This is a Google Earth image of a place in the far northwest of Australia called Kimbolton. This area has been heavily folded. We can see, if we zoom in a little bit, the folds in the rock that are clearly visible even from a satellite image. You'll have seen in the video the horizontal falls. Let me show you where they are. The beds here have been folded, so they're pretty much vertical. That creates these long barriers to the movement of the sea with the tide. Where those barriers get breached, we get these really narrow gaps, and with it, the spectacular landscape and the spectacular features that you saw on the video. All of this is the result of the folding, creating these long parallel bays with these long parallel ridges between them. Okay then, what I'd like you to do now is press pause and have a go at question 10 on page 15. Complete those block diagrams, draw in the axial traces on the side and the top. You could also draw in some dip arrows for those beds on the top surface. And finally, name the type of fold. Have a go at that now. Okay then, let's see what you've come up with. So this is diagram A. Let's fill in the gaps first, shall we? There we go. We can see if we look at these beds, this is an upfold. We've got the axial plane running through there, joining together the hinge points. So fairly obviously, this fold is an antiform. Okay, so this is fold B. Let's fill in the gaps here. There we go. So we can see we have a down fold here. Let's draw in the axial trace there. So this clearly must be a synform. And finally, block C. Fill in the gaps here. And in this case, we've got two folds. Drawing some axial planes. So there's one, and there's a second one. So we can see then we have both an antiform and a synform next to each other. Remember, you can't have two antiforms together. It needs to go antiform, synform, antiform, synform, and so on. Okay, as we watch the sunset over the Kimbolton coast, we can see the compression of rocks when they deform in this ductile way will form folds. That can be the first stage um, in faulting, where the rocks bend before they break. But we do see the effect of this both in rocks on a small scale and even in landscapes or even as big as mountain ranges on a larger scale. What we need to do next is to start thinking about the effect of tilting rocks has on the stability of those rocks if you want to start building things on them. But that's very much for another lesson. I'll see you then.